Example 3.4 is going to provide us with intuition about the derivative. So the derivative of a function. So if this function is called, let's call it f, then the derivative is going to be called f prime, and it's going to be a function of x. Right? If this is a function of x, then the slopes of our function is going to depend on x, right? Over here, the slopes are negative. Over here, the slopes are positive. And let's estimate the value of the derivative at a few points. So notice we don't have the definition of the function, so these are not going to be exact derivatives. They're just going to be estimates on the graph. So let's look at the derivative when x is equal to 2. So there's x is equal to 2, and I'm going to zoom in there. And I'm going to switch colors. The derivative is the value of the slope of this tangent line. So what's the slope of that tangent line? How fast is the function increasing or decreasing there? It seems to me like if I go over by, so this turns out to be 0.4 units, considering my scale. If that's 2, then that's 4, then each one of these gaps is 0.4. So if I go over by 0.4, it looks like I drop down by 0.4. So over by 0.4, down by 0.4, my slope is -1. So the slope of this tangent line is -1. Let's switch to a different color and move to a different point. All right, at x is equal to 4. So there's x is equal to 4. Let's zoom in there. Let's sketch what the tangent line might look like. And it's at the very bottom of my curve. So it looks like it's horizontal. I like to think of fixing a tangent line at a point and then taking this point and dragging it along my curve. When I get to 4, I'll have a horizontal tangent line. So horizontal tangent line means the slope is 0. So I think that the derivative there is 0. Let's change colors and move to a different point. The slope of the function, or the value of the derivative at 6. So there's 6. Let's zoom in. It looks like if I move over by 0.4, then I go up by 0.4. So here, I think my slope is +1, right? If I move to the left by 0.4, then I drop down by 0.4. So if I had to guess, the slope of that tangent line there, the value of my derivative is +1. All right, change colors, move to a point. The function at 8. So over here is x is equal to 8. Let's zoom in. If I move over by 0.4, I go up by more than 0.4. And again, this is a rough estimate. Maybe I go over by 0.4 and I go up twice that, by 0.8. So that means my slope would be 2. So the value of the derivative at 8 is the slope of the tangent line. It's increasing at a rate of 2. Notice this is increasing. This was also increasing, but the value of the derivative is bigger than the value of the derivative, or the value of the derivative at 8 is bigger than the value of the derivative at 6, because this tangent line is increasing faster. It has a steeper slope. All right, changing colors and moving on. -4. The value of the derivative at -4. So going over here at -4 and sketching a tangent line. So it's definitely decreasing. It's decreasing quite steeply. If I had to guess, I go over by 0.4, and I'm going to drop down by more than 1 unit, maybe 1.6. And again, I know what this function is, and I know that the derivatives are going to be nice numbers. As a rough guess, we're always going to stick with the integers. The derivative there might look like -4. This red line is decreasing quite rapidly. And then our last point at 3. So let's clear off the board and zoom in on the x value of 3. So immediately, by looking at the tangent line, we know that the function is decreasing. The tangent line has a negative slope, so the value of the derivative is going to be negative. We know that f prime of 3 is going to be below 0. If we had to guess at what it was, I go over by 0.4, and I really don't drop down that much at all. I maybe go over by 0.4, and I drop down by 0.2, meaning that my slope would be minus 1/2. Again, these are just estimates, so I'm trying to use nice numbers. So the slope of the function at 3 kind of looks like minus 1/2 to me. So the big idea here is the derivative is a function of x, and it gives me the slopes of my tangent lines. It gives me the slopes of the original function f of x.